now. Okay, so today, as I said before, I want to go through a quick example of a transformation question in word form, which you would have to read and identify A, K, D, C from the story. From there, I'll walk through a very quick 5 mark assignment that I want you to do using Desmos. It's basically getting you to practice using real life data and modeling it and not just some story from a textbook. Okay? If you are having some trouble with identifying AKDC, okay? Um, Practice makes perfect, really, in this situation, I suppose. Here's a couple of things that I'd like you to watch out for when we're dealing with stories. The diameter of something. So anything that's rotating circular, the diameter of something is going to give you a clear idea or clear indication of what the amplitude will be. The passengers can get on from the lowest point of the ride. So my ride starts at the lowest point, hint hint, and that is 3 meters above the ground. That might not seem as important, however, that helps us with something else. Lastly, a full revolution can be made every 20 seconds. So these 4 pieces of information refer to AKDC, but not respectively. Take a look. If a diameter is 80, that implies that the radius is going to be 40, right? So from the midline, I'm going up 40, coming back down, and then down 40, coming back up 40, so on and so forth. In other words, for a circular motion, the radius is the same as the amplitude. So this diameter will tell you that the amplitude is 40 right off the bat. Next, it says something about being the lowest part of the ride. In other words, I start at the minimum. That's as far as I'll go for now. Stay tuned. We're going to get into that really deeply later. The ride is 3 meters off the ground at the lowest point. That might not seem like a direct, like you might think, oh, is C equals 3? No, not necessarily. Once again, if I were to draw a dotted line on a Ferris wheel, and you know that the ride goes up and then down and then up and then down, I am always returning to where the center of that wheel is for, yes, sorry, I'm always returning to the height of that central axis, that mid-axis, which happens to be where the middle axle is for the Ferris wheel. So if you want to coincide those 2 pieces of information together, you will see that essentially, if you can figure out where the mid-axis of the Ferris wheel is, that is going to be my C value. I'm hoping that makes logical sense. Once again, the C value is the full radius of one circle plus the extra 3. That's how far off the ground the mid-axis is. That's going to be 40 plus 3. My C value for this story is going to be 43. And maybe I'll draw that arrow. That's a 40. Oops. Any questions so far? I think I'm just making logical sense. Remember, all of this you need to be able to do on your own. So if you're not sure how you might get to these conclusions with your own logical deduction, you're going to have to reach out, either practice or ask me some more clarification or some more tips. Lastly, 20 seconds every revolution, that basically reveals that each period, PER, is 20 seconds. What does that tell you about the K value? Remember, by the formula that we talked about last class, the formula for K is the old period divided by the new period. In other words, old period divided by the new period, the k value we're going to have in our equation is going to be 12. So we have A, we have K, and we have C. What is D? Now D is going to be the hardest one, right? You have to really look at it and use some logical deduction because there's no real calculation involved per se. Take a look. Passengers get on from the lowest point on the ride. So if I were to draw a graph, you could say that I'm actually starting from the lowest point. And I'm doing this. What does that mean? Well, let's pretend you wanted to use the parent function as sine, and we'll also assume some other people may want to try using cosine as your parent function. Okay? Each of them, both of these, whether I use sine or cosine, that's sine, and cosine is this. Regardless of which curve I want to start with, I need to change or do a phase shift so that I start at a minimum. Right now, this curve is quote unquote starting, in other words, the y-axis, starting at the central midline. For the cosine, I'm starting at a maximum. So let's pretend I want to just muscle through. I'm not going to use any special tactics. If I want to shift this so that I start at a minimum, I'm going to either have to shift this 1/4, 2/4, 3/4 to the left, or remember that a minimum is right there as well. So I can technically take this curve, sine curve, and shift it 1/4 to the right. This is what I mean. This is my sine curve. I could move the sine curve 1/4, 2/4, 3/4 to the left, or 3/4 of a cycle to the left to match my story, or I could shift it 1/4 to the right because I know that sinusoidal curves are continuous, so I know there's going to be another part right there on the other side. What I mean by this, in case you're still not following, is remember that a sinusoidal function is actually forever. So I can move this 1/4, 2/4, 3/4 to the right, or to the left, or I can move this 1/4 to the right so that I begin at a minimum. If I use the cosine, I can move this 1/4, 2/4 to the left to begin at a minimum, or I can move this 1/4, 2/4 to the right to start at a minimum. Because remember, just like the sine, the cosine is continuous. 1, 2, or 1/4, 2/4. So there's two different ways you can do it, which means there's more than one equation. Oh, sorry, there's two ways using cosine and there's two ways using sine. In other words, I already gave you four different potential equations. But let's be a little crafty here. What else could you do, especially with the cosine, to match my curve here with this equation? Anyone have an idea?
Could you flip it?
Right on. That's exactly right. If I were to take this and I flipped it upside down, I already have my minimum to begin. So if I were crafty enough and be like, oh, this is just a vertical reflection, I can, instead of this, I could just add if I add a negative in front of it, I basically changed this curve to be upside down, and I have effectively forced the curve to start at a minimum. So I don't have to worry about a d-value. So long story short, this d-value could be more than one number as long as it makes sense. This is why you're going to have to think about it. It is not something you memorize. It's just sort of you have to have a bigger understanding, a larger picture of this, at least in my opinion. So I'm going to be crafty. I'm going to pretend I recognize that this is a minimum, which is a vertical reflection from a maximum. So I'm going to stick a negative in front of the cosine. My final equation it could be um, negative 40 cosine 12 x minus d, there is no d, plus 43. So I'm going to still muscle through. Let's pretend you didn't know to vertically flip it. How do I get from this cosine to the one on the left? I would have to move half of a period to the left. Well, what is one period? One period is 20 seconds. So what's half of a period to the left? 10 seconds. So another potential equation you could have given me is, let's use a different color, red. Another one that is just as correct is a positive 40 cosine 12 and then half of a period to the left. And this would be just as correct and you get full marks. I'm going to force the issue further and I'm going to pretend we're using sine, the sine function. If I'm using the sine function, this curve would have to be moved 1/4, 2/4, 3/4 to the left, or, if you remember, because the sine curve continues on forever, all I have to do is move it 1/4 to the right. So since I moved left for the cosine function, how about I move 1/4 to the right this time? If I used my sine function, I would get full marks, or I would give full marks if you gave me 12, so 40 sine 12, and then a quarter of a period to the right, a quarter of 20. So 1/4 of 20 would be 5. I am moving 5 to the right plus 43. All of these are correct. Any questions about this particular thing? The reason I give you this is because you might have seen the post on your Google Classroom already. You are going to be given a quest to do sometime next week on your own time, and I'm trying to be as accommodating as possible. My hand was forced because we don't have much time left in class. I have to spend it for instructional time, um, which means the evaluation that I have, it can't be in the form of a test. I just turned it into a form of an assignment that you have to do on the spot. Okay? So it is what it is. Do your best with it. You could do it anytime you want from Monday at 8 o'clock when it's released all the way to Friday when it's due at midnight. And then from there, it's going to be closed. If you feel that because of some reason you cannot do any of the work, any of the, if you can't do the quest at any time next week, which I don't think it will be an issue, but if it is an issue, you're gonna have to reach out to me ahead of time. Just tell me ahead of time saying this was pre-planned from like months ago and It just so happens to be right on this week and I can't do it, Mr. Kim. You gotta let me know. If there's silence, then I'm gonna assume that this is totally okay, and if you don't do it, it's a zero. Okay? Questions or concerns? No? On chat? Okay. So I'm gonna assume everyone's okay with this. I'm going to go ahead and clear. I'm gonna walk through the 5 mark assignment. If you have the handout with you, you will see that the front and the back is virtually the same. The front, though, and the back have a different set of data points. The front that we're going to do together is a data set describing the height of water as there's high tide and low tide on a lake or something like that, or sea levels. The back, which you are responsible for, I believe has to do with temperatures over a year. Okay, the front, high tide, low tide over a day, 24 hours. In the back, the one that you're supposed to do for marks is temperature over a year. So we'll see how that looks. I'm going to share with you the sheet so that we can do it together. As I do this sheet and as I as I model what you're supposed to do, if there's anything that I do that you think you might forget when you do this assignment on your own, I'm gonna ask you to make a little note of it on the sheet so that you don't have to, look at this video again. Okay, that you know exactly what you're supposed to do. All right, so sharing this screen, I'm gonna zoom in. You are going to be, so here it is. I'll read it from the top and you'll see what you're supposed to do. There's a variety of natural phenomena that can be modeled with a sine or cosine function. You're going to use what you know about the properties of sinusoidal functions, so period, amplitude, max and min, blah, 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 to find a sinusoidal wave of best fit. So a sine or cosine curve of best fit for your specific data set. So what you're going to do is take the data I give you and plug it into desmos.com. And if you are not familiar with desmos.com, I want you to write this down. It is literally just desmos.com, which is a freeware. It's just a website that is coded to be a very user-friendly graphing system. It's becoming more and more well known and more powerful, so that it's to the point where the designers of this are sort of pairing with mathematicians and creating material that teachers can use as an exercise for their students. Lucky for you, I'm not actually giving you any of them, but it's still a very powerful graphing program. You are going to calculate from this data set, you're going to calculate amplitude, period, phase shift, and vertical translation. I'm going to ask you to create an equation for me and then also use get me the computer generated equation to compare, and then you're going to sketch it. All right, so let's see how this works. Um, Going way down. So this is the data of a 24-hour period. You are going to plug this in and let's figure out the period and amplitude after I plug it in. So here's what you do for your assignment. You would go to desmos.com like that. Everyone here see the website? Can someone confirm that you see
Yeah.
Desmos right now?
Yeah.
Okay, perfect. All right. Then so you're gonna see this website. Just click on the little tab that says Graphing Calculator, this little button, and it will go straight into this graphing interface. It's really cool. You're gonna take note of the little plus on the left side and the little wrench on the right. Those are the only things that you have to know specifically. Everything else is pretty straightforward. So first things first, the exercise gives you a data set. I'm going to plug it in. My independent variable is going to be hours, so 0 all the way to 23. My dependent variable is going to be height in meters. It goes from 4.9, it goes down to 0.2 is the smallest one, and then it goes back to close to 4.9, and then it goes back to 0.2. So I think we found our max and min there. Here we go. First off, you might want to put a little note. Okay. Please click on that little plus. Okay. So what you might want to put in your handout is if you look at the top left, press the plus button. It'll give you a small menu where it will let you add a table. Okay, so take a look. I'm gonna click the add button, and you see that? Add a table. And when you do so, it'll give you an X and a Y waiting for your input. Okay, top left, press the plus sign, add table. What you might notice about this table is that it's labeled not as X and Y, but X1 and Y1. You can imagine there is a possibility that someone wants to add multiple graphs on there. Like maybe you want to put a y equals mx plus b, you want to put a parabola, you want to do a sinusoidal. There could be a lot of different graphs. The computer doesn't want to be confused between x's and y's. And so for the first xy relationship, the computer will just say x1, y1. Remember, this is a computer, it's coded, so it can't, if you use the same x for two different definitions, it's going to get really confused. Okay? So make sure you see x1 and y1 because you're going to be using x1 and y1 later on. Here we go. 0, 1, 2, 3, 4. Oh, it automatically fills for you. So you're going to press enter. There you go. Next, I might have to go back and forth. I should have a spare handout with me. I guess I don't. Okay, this might hurt your eyes, so just close your eyes while I flip back and forth. 9, 4, 3.6, 4.9. Oops. Okay, 0. 4.9, 4.5, 3.6. I wish I had a keypad. I'm a lot faster with this than a keypad. 1.2, 0.4.2. 0.4.2. Are you serious? 4.4, 0.2. And then 0.5, 1.2. 2.3, 3.5, 4.4. 2.3, 3.5, 4.4. And then 4.870, 2.9. 4.8, 4.7, 4.0, and then 2.9. 1.6629. 1.662639. If you see an error, please let me know. 1.934.1. 1.934.1. I think I got it. So right now I'm just gonna click and drag. I see that the wave is looking nice. What I want to do is you can either zoom out, but what else you can do is make sure you set the tone, set the axes to be fitting for you. What I mean by that is click on the right top wrench. Okay, this is going to be an important tool that not only fixes your X and Y axes, but also makes sure that you are using it in degrees. So I'm going to clear all this. Please press the wrench. First thing you want to do is make sure we're in degrees, otherwise your equation will be really weird. Next, on my x-axis, I go from 0 to 24, so maybe I want to limit it. Actually, yeah, maybe -5 and all the way to 30. And it fixes my x-axis so that you see a -5 and you see it all the way to 30 as my maximum x value. Next, And maybe I want to show the steps in one. We'll show everything. That's a little messy, isn't it? Let's just do that. Next, my y-axis, maybe I want to, have a little less room. Maybe I'll start at -5, and I want to go up to 7. Bam. If I do that, it essentially fixes so that my lowest point is a -5 and my highest point is a +7. In any case, I like this as is. Okay. Yeah. Any questions so far? So as a quick recap, I think what you need to remember is there's a plus sign which lets you add data, and this wrench lets you change it to degrees. Okay, let's keep moving. All right, now I'm going to ask you to analyze this data as best you can. We're going to create an equation without the computer, and then we'll use computer later. The period. What is the period of my function? So if you take a look at this is a 24-hour period. What is the period for one cycle? Hmm? What do you think? I'm thinking, I hope you're participating and not just sort of being idle. There's one cycle, and then there's another cycle where we repeat. So I would imagine from 0, I finish a single cycle after 12 hours. So go back to the sheet. I'm going to say that my cycle is 12. My period is 12. So what is the real meaning behind that? So the number itself is 12. What does that mean? It would mean, let me change the color. Okay. The real world meaning of the period 12 for this equation, in the real world, it means that the tide will rise and fall every 12 hours. It is one full cycle. Okay. Next, let's talk a little bit about amplitude. I might have to draw something here, so let's do it. The highest point, my maximum point is 4.9, and my minimum point is 0.2. I go back to a high, I go back to a low. So if I were to draw a quick sketch, my low is a 0.2, my high is a 4.9. What's my max range? What is the space between that?
4.7.
Yeah, it's 4.9, it's a max minus the min, right? The amplitude tells me the distance between a max and the midline and the min and the midline. And so to find the amplitude, it makes sense to take these two numbers and create an equation. It's 4.9 minus 0.2, and you divide by 2. So the amplitude would be 2.35. And that's actually a formula I think the textbook introduces. I never particularly liked it because it gets you to memorize it again. But for those of you who actually like to do that, it's max minus the min divided by the 2 gives you the amplitude. What is the real world meaning behind an amplitude of 2.35?
Does that mean it'll reach a peak height of 2.35 meters above,
Above.
like, I don't know,
You're
the
right.
midpoint?
So
I don't know what to call that.
An amplitude of 2.35 would be the tide rises and falls 2.35 meters above or below the resting sea level, whatever sea level is. Right? So if there's absolutely no movement, the sea level of the Earth or sea level of that particular location would be whatever, right? Amplitude means I go above that by 2.35 and I go below that by 2.35. Okay, I think we have all the information we need. Let's create an equation now. We've we've confirmed that the amplitude is 2.35. My k value is 360 old divided by new, which is 30. My k value for this equation is 30. Um, my d value, let's take a look at our graph. Ooh. Here, let me see if I can erase all this and then bring it back later. Okay, d value. How can we deal with the d value? How can we get a curve to start at a maximum? What are some ideas you have? Anyone? I'll give you a clue. I'll give you a clue. Uh-oh. Oh man, I can't bring it back. Oh well, that's fine. I'll give you a clue. Notice that my tide starts at a maximum. So I could use a sine curve and then I could shift it over so that it hits right at, we begin at a maximum. Like what I could also do is use a curve that already begins at a maximum. So it's up to you. All I ask for is a sinusoidal curve, so you can use a sine function or the cos function as your parent function. If I use cosine, I don't have to worry about the phase shift, so why not just use cosine, right? A is going to be 2.35. My k is 30. My d is going to be 0 because my cos x is going to be used as the parent function. All that's left is c. This might require a little bit of logical deduction. Remember, please, my highest point is 4.9. My lowest point is 0.2. What is the number perfectly between 4.9 and 0.2? Perfectly between is sort of like saying, what is the average between 4.9 and 0.2? It looks it looks oddly familiar to our calculation of amplitude. This is why I don't like memorizing it. So many students have made silly mistakes with it. My C value is 2.55. So again, if you like memorizing, let me rewrite this. For amplitude, it is going to be max minus the min divided by 2. But for the mid-axis, in other words, the C value, you take your max, you average it with the min. And C value is 2.55. Final take. If I use cosine, my equation that fits this data would be amplitude of 2.35 cos square brackets k is 30 x, there is no d, so I can leave that alone, plus 2.55. If you decided to use sine, there's definitely going to be some kind of phase shift. And I'll let you figure that out because we've done a lot of practice with that. How is that? Any questions? We're not done yet, but so far, any questions? No? All right. And here's the last part. To tell Desmos to find an equation for me, you are going to not use an equal sign. You're going to say it's approximately equal to that. This is how you put in the code so that Desmos does its work. You say that the y value, and not just any y value, remember, y1 is just equal to, and please note this is in your keyboard. Everyone should have their keyboard in front of you. Look at the top left corner of your keyboard. There should be a button that has a tilde and a little apostrophe on it. Okay? You press shift and that button, you should be able to get tildes. Okay? So if you want to put a little reminder, this is top left of keyboard. Well, to be honest, it's just a little, it's a symbol. For Desmos, for a code, like for the Desmos interface, tilde means approximately. Do you know how when you're in math, you're like, you want to say y is somewhat like approximately equal to? It's that same idea, it's that same symbol for the computer when you use the tilde. Okay, so y1 tilde, and then just type in a cos, open a bracket, k, open a bracket, x minus, x1 minus d, close both brackets, and c. If you type this exactly as you see here inside Desmos, Desmos is coded to recognize the y1, it recognizes the cosine, it recognizes the x1, and all the other letters attached to it. It knows that they are variables that it needs to identify using its programming. Okay? It is. So this is what approximately means. But for Desmos, we don't have that in our computer, in our keyboard, right? So to represent this in the Desmos coding, Desmos will use this and interpret it as approximate equal sign. So take a look at how that works. I'm going to switch over. Where is it? I'm going to switch over. It's a bit messy, but take a look at this bottom part, okay? I know all this weird stuff is here. I'm going to, actually, you know what? Let me take this and make it a little smaller. And I'm going to move this aside so that you can see the wave coming in. All right, here we go. I'm going to type in y1. And when you type in y1, the Desmos program automatically knows to put it as a subscript of 1. So you don't have to do anything special. So y1. What the heck is happening? y1. Tilde. And you see a little exclamation mark saying, hey, you need to give me more if you want me to do an equation. A. Cos. Open a bracket. K. Open a bracket. X1. Again, it knows to do a subscript. Minus D. Close bracket, plus C. Bam. It automatically matches all the X values that you see in the chart here, and it makes it equal all the Y values that you see in the chart here, and it gives you the equation. What equation is it? Take a look at these parameters. I'm going to zoom in. Right there. The parameters state that if I want to have an equation, my A value would be 2.36, K is 29.063, and you get the point. Okay, so I'm going to bring this back to our Google Classroom. I'm going to type it in right now and then I'll transfer over. That means f of x, according to Desmos, should be 2.3641 cosine of 29.0693, open a bracket, x minus a negative value, so x plus 0.167762, close bracket, plus 2.49189. Wow. I'm going to switch my screen over to our handout, and I'm going to use my selection tool. So this would be my equation given to me by Desmos. Take a look at how close that is with our original equation. Our original equation was 2.35 cosine 30 x minus 0 minus nothing plus 2.55. It's really close. And so the last bit, your simplified equation, just take all of these decimals and maybe round to 2 decimal places. So f of x would be 2.36 cosine 29.07, open bracket, x plus 0.17, close bracket, plus 2.49. And then you sketch. And yes, you can sketch by essentially copying and pasting from the Desmos curve, Desmos program. Okay, so that's essentially it. Once again, just zooming out, I would like you to go through the data, plug in the data, right, of the sheet on the back, plug in this data, and then find the curve, set the parameters so that you get it in degrees. Identify period by looking at how often the cycle repeats. Identify the amplitude by checking out the max and min. Tell me what the real world meaning of that period and amplitude is according to the scenario in page 2. Okay. Write an equation to fit this data. Oh, for some reason the simplified equation is missing. Oh well. Give me the equation that you would have done as a human being. Use Desmos to give me the equation, and then just simplify that equation for me. Oh, I don't know why this happened, but you get the point. Give me the simplified equation and then sketch the graph for me. Okay? Any questions? Oops. No? Okay. I hope it was pretty straightforward and self-explanatory. Please don't forget the initial practice question that we did with the Ferris wheel. Stuff like that would be useful for you. And then this quick 5 mark thing just to show me that you are able to take real world data and do something with it if you needed to sometime in the future. Show me you can do that and we're good. It is now 2:50, and if there aren't any questions directly on this, I will stay here uh, until the class is over to take any other questions you might have, whether it's for um, other assignments and whatnot. If you want to spend this time doing some other work, you can. For your benefit, before you go, I'm simply going to write out a list of things that people should be doing in case you start getting swamped, okay? To-do list. This doesn't apply to everyone, but there are still people who have not done the quiz for a chapter 3.1 to 3.4. That's the exponent stuff. Please go do it. You may also have noticed there is a quiz for cast rule. People have not done yet. And now there is I believe, is that it? Yeah, I think that's it in terms of quizzes. Some people still have not done the transformation assignment. That's worth 10 marks. Very quick, but so easy to get 0 to, and you don't want that on your record, okay? There's also the optional sine cosine curve. And as you can see, we've been working with sine and cosine so often that it's, it's like beyond easy to get these marks. I really hope that you'll be able to do it. What's next? The triangle, so the chapter 4, sine law, cosine law assignment, plus the trig identities worth 20. You should have that done by now, but if not, just organize your time and do it. And then lastly, of course, the Desmos assignment, that's worth 5. This is all stuff that people should have like started hammering away. Okay. Um, if this is you and you haven't done any of this stuff yet, or you're just, you know, I need you to do as much as possible before the weekend is over so that I don't have to send not so nice emails. Okay. So all the quizzes, you should be able to do it tonight. Right? If you want to study off of it, that's a little different. But if you have done it and you've been keeping up, there's no reason why you can't do these quizzes, especially if you can go back and check your answers. The transformation assignment, where you just create a random curve and apply any type of AKDC for transformations to it, and then you try it, that can be done, in my opinion, within 30 minutes. Okay. Same with this one. You need 36 points. Essentially, you're doing sine 10, sine 20, sine 30 degrees, so on and so forth, and give me 36 points to create the nicest sine curve possible. Add a little bit of flair, right? That shouldn't take more than 30 minutes either, in my opinion. Okay. The sine law, cosine law question with the ambiguous case and 3D triangle imagery and the trig identity, that might take a little bit of time. And so this, why not just leave last? Okay, I already gave you a week to do it because I released it, I believe, last Friday. If you haven't done it yet, forget it for now. Leave last because all these other ones are so easy to do and they're worth a decent amount of marks. And then, of course, the Desmos. Figure out what you want to do. Maybe do the quizzes tonight. Maybe do these two small assignments tomorrow, so that's Saturday. Okay? Even this one, I was walking it through with you and I was able to finish it in less than 30 minutes. This one's going to be another 30 minutes. Why not just do all of these 30-minute assignments on Saturday? Just hunker down and finish it. So that by Sunday, all you have to really worry about is this triangle thing. And then come Monday, the quest is going to be released and you'll be decently ready at least. Okay? Once again, before you go, if you are going to have some trouble doing it sometime between Monday and Friday next week, you're going to have to come and talk to me or at least send me a message. Okay? Any questions? No?